learn more focusing on the lecture 6 to lecture 8, the one that I covered in the second part of the semester. So still remember when I covered, I start off with the recap and advances in robotics. Basically, what I want is just to recap, although I just covered on the chapter 1 to chapter 5, but I want it to relate to the chapter 6 to chapter 8. So in the first half, remember by Dr. Johari, or if you are in PSAC, is covered by Dr. Buhari. You learn about the basic stuff of mobile robot. How do you actually build a mobile robot, isn't it? How do you actually design the hardware of the mobile robot? For example, you know, in a mobile robot system, you need to know what kind of the battery, the controllers, and so on, right? So it actually relates back to the application that you want to develop. So this one I don't think I need to cover, but then I just want to remind you again, you are going to be an engineer. So always, if you happen to be a robotics engineer, I want you to remember these 3 laws of robotics. You must make sure that the robot must not injure a human being. It will also obey whatever human give the order, and it must protect its own assistant as long as such protection does not conflict with the first one, second one, which is to must not injure the human being, and also not must follow the order by the human. Okay, I will not go through this. These are the recent technologies. And as to recap, the section 1 to lecture 1 to 5, basically you learn about the locomotion, right? Whenever you talk about locomotion, you need to imagine how the robot moves, right? Isn't it? Whether you want it to be biologically inspired, or you want it to be based on the the wheels and so on. So also you need to understand the holonomic, non-holonomic, wheel robot. You know that is the mostly being used, and the leg robot. Why do you want to use a leg robot? For example, in a certain applications, you want to use a leg robot because it's not flat, isn't it? Just imagine in a situation where the terrain is not flat. You have rocks, you have stairs, and so on. Then wheel robot might not be relevant anymore. So you need to have a leg robot in order for you to climb and so on. And also the swimming robot and the flying robot. So given that you have an application, you need to be able to design and imagine what kind of locomotion is the best to solve that application. That is what you want you to understand. Also later on in the in the exam also, we want you to be able to think about that. Nanti kalau kita this certain scenario, how do you design the locomotion, for example, something like that. Or let's say this kind of scenario, how do you calculate the, for example, the omnidirectional punya calculation, differential punya calculation, and so on. So you must be able to do that. Okay. And looking at the robot controller also, these are among the controllers. I know you probably have done using Arduinos and so on, but these are the things that you need to consider whenever you design a robot. And actuators, motor, brushless DC motor, stepper motor, servo motor, linear actuator. When you want to use a brushless DC motor, when you want to use a stepper motor, for example, stepper motor is more on the when you want to really get an accurate movement of a certain of the robot, or you want to have a very accurate movement of actuator. For example, you not control an arm or something like that, then you might want to use a stepper motor, right? And then the DC motor, for example, you need to also know how to select, define the specification of DC motor. Contoh DC motor, what is the specification? The torque, the force, everything. How much torque do you need in order to move the robot? Something like that. Macam if we give certain application, okay, this is application and this is requirements. So try to, you must be able to calculate what is the torque, what is the force, whether this DC motor is suitable or not, and these kind of things. Maybe also servo motor, maybe also linear actuator, and those kind of things lah. We want you to be able to do that. Okay, robot communication. Let's say I give you a scenario. Robot is located outdoor, located at the campus of Unimap, for example. And then I say, okay, we have a robot, 5 robots at the campus of Unimap, and then I have a base station located at our chancellery of Unimap, for example. Then how do you actually design the communication between the robot and also the base controller? How? Macam mana? Anyone has the idea? Contoh ada tak? Edmund, how do you think the communication should be? Can you use Bluetooth?
Bluetooth. Because the campus maybe don't have a Wi-Fi, and then we can use the Bluetooth to communicate with the robot.
Okay. You are saying you want to use Bluetooth for you to communicate between the robot, which the robot moves in a very big campus. Setuju tak? Pakai Bluetooth. Can you? Yes, Muhammad. Mat. Okay. Okay. That's another option. Yeah. But that is a correct answer lah. If we consider we are using Bluetooth, it's okay if the field is very small. If the field is very small in the campus, it's okay for you to use Bluetooth, because Bluetooth has very limited range, right? Probably 10 meters, probably 50 meters. That is the maximum, for example. But then if you want to extend the range, you want to use it around the campus, then you might want to consider something that is longer in distance, right? For example, you might want to use Wi-Fi if possible lah. Of course, if you want to use Wi-Fi, there is also a range which is 100 meters, but you can use, yang macam mesh, like mesh or something like that, right? For the Wi-Fi, you might also want to use LoRa, long range communication, LoRa. You can also use, macam Mat cakap tadi, you can use 4G or broadband or whatsoever. But then you need to consider, for example, let's say you use 4G, right? 4G might be a bit slow in data communication, isn't it? That is another challenge that you need to address. Kalau kata guna 4G, then what kind of, how do you solve it? Because it's slow. Probably you have a 4G to transfer certain data. Another data is transferred using different things and so on. So you have to be able to come up with that kind of thinking lah. Understand? What else? Let's say you have multiple robot. How do you communicate between multiple robot? Let's say in a industry. I give you, okay, I put 10 robots in the industry, in the factory. How do you ensure that the robot will be able to communicate between each other? What kind of communication that you want to use? Maybe you want to use Wi-Fi, right? Because within the factory, assuming that it's 50 by 50 meters, then probably Wi-Fi would be a suitable way for you to communicate, isn't it? Bluetooth maybe not that long, so might not be suitable. What else? So you have to have that, and then what else? Okay. Also the sensors. Let's say I want to use a robot in the factory, in the house or in the factory. Is it possible for you to use GPS? No, right? Because the GPS is only available outdoors. So what can you use if you want to use inside the building in order to perform, later on we will go to that, the localization, the SLAM and so on. You might want to use LiDAR, you might want to use sonar, ultrasonics, cameras and so on, right? Those that can be used inside the building. Okay, and also the robot power source. This is also very important. Whenever you design a robot, the power source is very important because you know that the robot is not connected to a fixed power point. You don't have a plug point connect to robot. If you have that, you know that the robot will not be able to move around, right? So you need to have a power that is inside the robot already, like a battery, ataupun you can have a solar-based mobile robot, or you might have a rail atau rail like line following, but then while moving on the line, there is a power supply along the line. Something like that can also be. Ataupun you have a wire up, macam LRT or commuter. There are certain technology that they use the power from the wire on top and so on. So these are the things that you might want to consider lah whenever you design an application. So, but most the most of the mobile robot will be using battery. When you talk about battery, what are the things that you need to consider? You need to consider the capacity, right? Because how long would the robot would be moving? The robot might need to operate for 1.5 hours, might need to operate for 2 hours, and so on. So this, if you want to operate it for that time, then you need to know how to calculate the capacity of the battery. So this is what you call as capacity, and the discharge rate as well. Let's say you want to have a drone. Kan? Drone is very intense in power consumption because you want to move the blades, right? You want to move the propeller. The propeller is very highly use the power. So you need to know what is the discharge rate of the battery, the maximum discharge rate of the battery in order to supply to the propeller and this kind of thing. So that's why whenever you select the battery also, you need to understand how to calculate the capacity, how to calculate the maximum amps, how to calculate the discharge rate, all these kind of things. I believe you only learn it in the lecture 4 or 5, something like that, under the Bukhari or the Johari and so on. So okay, I think all this you need to understand before you are able to move to the next section, which is you want to make it autonomous, right? So before you able to make the robot to move, you need to know first how to design a robot that solves the application. Once you make that robot, now you know that robot is able to move, able to get the data of surrounding and so on. Barulah kita go to the autonomous intelligence and application base, which is those lectures that is covered by me, lecture 6 or lecture 8. Okay, so now when we talk about localization, sorry, before that, when we talk about autonomous mobile robot, okay, when we talk about autonomous mobile robot, there are 4 key issues. There are 4 key issues that you need to consider. The first one is localization. Second one is environment and mapping. Third one is path planning. And the last one is navigation. Why these 4? Because whenever you want to move, for example, the robot from A to B, let's say you see here, is from A to B. From A here to B here, right? So you know that to move from A to B, the robot must know first where is the location of A and B, and also must know first where the robot is, isn't it? Where the robot is. So this is what you call as the problem of localization. The robot must know where it is before it will be able to move to that location. Second one is environment and mapping. Without knowing the environment and mapping is actually you want to know what is the environment, right? Where is the obstacles? How far is the distance? How does the environment looks like, and so on. If you don't know this, you will not be able to plan for the path later on, right? So that's why environment and mapping is important. Next one is path planning. Once you know where you are, you know how the environments look like, where is the obstacles and so on, then you want to plan the path. How do you go from A to B? What is the shortest distance and so on? What is the most efficient movement to from A to B? Where you see the path here, macam ni. These are the path planning lah. How do you get from A to B in a planning lah, not a movement yet. When you talk about navigation, the fourth issue is actually you know the planning how to go there, but then how do you go there? How do you actually execute there? Because you know when you are moving, you might have obstacles at the you might have obstacles when you are moving. You know, probably while you are moving, you will not be able to control the wheels exactly like the path that you plan. So this is a problem of navigation. How do you follow the path from A to B? Okay, so these are 4 issues. Again, okay, robot location also is referred to post. Okay, there are a few ways for you to solve localization, which is GPS and then beacon, head reckoning, and so on. You can also use a lot of things. You can also use like camera mounted on the ceiling. Camera mounted on the ceiling you can also use, for example, in the factory. Tapi it will be a bit challenging because if you need to have a lot of cameras, right? If the factory is very big, then you need hundreds of cameras to cover the entire area. Then when you have that, you need to be able to merge all the pictures of the camera, and then you know, after that, then you know the environment, right? So it will be challenging a bit if you are using this. This is more suitable for a small environment. You can use also like map base. Let's say you already have a map from the SLAM or something that is stored in the robot. You have a map already, then you can use that map for the localization using laser scanner. This is actually covered in the lab 2, isn't it? Lab 2 last time I showed you two things. One is SLAM, another one is localization. SLAM is where you actually combine the localization and mapping, do it simultaneously, because for you to do localization you need a map. For you to map the environment you need the localization as well, right? So both are dependent to each other. So that is what you call as a problem of SLAM. But then once you get the map and store it inside the robot already know the environment, then when it moves, it would be able to localize itself within the map, right? So this is what we call as localization based on the map. Localization based on the map. Okay. And for the map, there are 2 types. One is topological, where it is based on the, you know, it's relative between nodes to nodes. For example, you have a few rooms here, right? Few rooms. Then you know what is the distance between this room to this room, node to node, like that. And then from this room to another point that you already put in the graph, like this. So this is what you call as topological. It's not actually getting in terms of the obstacles and so on. It's just a relation between one point to one point, okay, from one node to one node. So normally in the topological you have 2 things. One is node and another one is edge. Node is one the point that you want to measure, and then the edge is actually the distance between the nodes. Right? I'm not gonna play the video. Another way is continuous line base, cell decomposition, and this is the one that is always used. We call it as occupancy grade, and it is based on the space itself, the obstacle. Where are the obstacles, and where are the free space, and the unknown or unexplored cell. So you normally put 0 as a free space, 1 as occupied cell, and 2 as unknown. You can put any numbers, no problem. But then there must be a way for you to differentiate these three things. Okay. So as you can see here, for example, the white here shows that it's free space, black is actually the occupied cell, and the gray area here is actually the unknown area. Okay, never mind. We go into that later on in the path planning section. Okay, SLAM just now I already mentioned to you is actually a simultaneous localization and mapping at the same time, and this is an example. Okay. Okay, so let's say you must be able to understand all these terms. Localization. What is localization? You must be able to understand. Localization itu apa? Tadi kan ada definition kan. Must be able to describe it lah. And also let's say SLAM. What is SLAM? What does it mean? Yalah tadi simultaneous localization and mapping, but then you should be able to elaborate what does it mean lah. Right, you need for you to localize, you need map, you need localization. So it's a problem of localization and mapping simultaneously and so on. Okay. And these are the applications of SLAM. You can use it for vacuum and so on. This one. Okay, any questions so far? Any question? I just go through quickly, yeah. Those that is important for you. Macam ni ah, this one. Let's say we show you a robot. What you need to be able to describe the robot. You need to be able to know why you choose certain component on the robot and so on. Any question?
No.
No.
Okay. Now let's go to path planning. So path planning, once you get the localization, you get the SLAM and so on, then you path planning is where is the problem of finding the path or the movement of the robot in order to move from point A to point B, right? And for you to do that, normally in the problem of occupancy grid map, for example, like this one, you normally have a shortest path planner, and then you do an optimization to make sure that the path is actually optimized. Right, this one is okay. Okay, let's go to the calculation part. There are two main path planning algorithm that you learn in this course. First one is Dijkstra. Second one is A star, right? So let me ask, which one is more efficient? Data 3.
A star.
A star. Why A star is more efficient? Why A star is better?
Faster.
Why?
Faster.
Yeah, faster. Why?
Less operations.
Less operation. Okay. Why less operation?
You didn't need to find the values for cell, for each cell in the map.
Okay. Why you don't need to find every value for each cell?
Dijkstra need to find every possible step while A star don't.
Okay. But why? I'm digging you.
Because for the A star, you know the goal. So
Huh?
for the A star, you know the goal.
Okay. What do you mean by you know the goal?
You have the point, the goal point.
Dijkstra also you know the goal. You know where is where is the starting and where is the goal, right? Otherwise, you will not be able to find the path.
A star calculate the path with the direction of the goal, while the Dijkstra calculate with all direction.
Okay, near already. Near to the what I want you to answer. What else? Why A star is more efficient?
Leading towards the goal.
Again?
A star gives shortest the distance.
A star what? Again?
A star gives short distance for
If you
the goal.
calculate Dijkstra and A star, you will get the same path, right? Both are giving shortest path. But what we want to say here, Dijkstra and A star, which one is more efficient? Which one is faster? A star, right? You say A star, that is correct. But why? Just now already say, okay, faster because you know that's near already. You have all this. But then one important point that you missed. What additional calculation that you have in A star?
Self current distance with the starting distance.
No.
The distance between the current cell to the goal cell.
Yes, that is. Distance, the shortest distance between the current cell to the goal point, you have that information, isn't it, for the A star? Correct?
Yep.
You have the age there. If you remember the A star, the calculation is F equals to G plus H. Later we go into that. But then H just now is the shortest distance between that cell to the goal point. Okay, please. Siapa yang tanya? Siapa yang angkat tangan tu? Yes. Go on. Siapa? Siapa yang angkat tangan ni? Tak jadi ke apa? Okay, tak jadi. Alright. So that is the important point that you need to understand. Whenever you have A star and J star, A star is always better in terms of the computation. It's always faster. Why is always faster? Because A star you have additional information, which is the distance, the straight line distance or the shortest distance between that cell, any cell in the map, to the goal. Right, you have that information. With respect to Dijkstra. Dijkstra, you don't have that information at all. You just expand in all direction, and at one point you find what is the shortest distance to the goal. But A star, you expand in a way that it is shortest towards the goal point, right? Because you have the information of what is the shortest distance between each cell to the goal point. So it would expand to that direction, right? So you don't need to calculate in each direction, you need to calculate in that direction only. So that's why it's more efficient. It is more and more efficient whenever you see a very big map and also you have a lot of obstacles. Then you see, oh, A star is a lot more, but because you don't have that in the all this example, right? So you tak nampak sangat lah actually. Why is it more efficient? Okay, let's go into Dijkstra. So let's revise a bit. How do you actually perform a Dijkstra algorithm? This is based on the topological map. You just know what is the node and you know what is the hash between the nodes. Right? It's not occupancy. Let's look at this first. Okay, let's say you have 5 nodes there: S, A, B, C, and D, and you want to the starting point is S and the goal point is D. So the first step that you want to do is for the A star. The first step that you want to do, you want to know you need to determine what is the possible node that you can move to from S, because S is starting point, right? So from S, you can only move to C, D, and A, right? Betul tak? S, C, and D. You can move to C, D, and A. So looking at these three, looking at A, C, and D, this is where you want to update later on. So when you start, actually, you want to put all the numbers there as infinity, because you haven't started yet, because you haven't calculated yet. But then when you start, you need to fill in the number inside the nodes. Okay, now from S to C, S to C is, that the distance is 5 just now. So you just fill in there, the 5 over there in the nodes, right? So you put S, because S is the predecessor, and then 5 there, right? S5. And then to A is S predecessor, and the distance is 10. So you put 10 over there. And then to D is S and 9. Okay, I believe you already understand this. I go quickly. So now, based on this, you see that C is actually the lowest value, right? It's only 5. So now you select C. You want to expand from C. So from C, you can go to where? You can go to A, you can go to B, and also you can go to D. So from S to C to A, for example, right? From S to C to A, you need 5 plus 3 there. So that's why you update that 8, and predecessor is C. So because 8 is actually lower than 10, so you slash the previous one. Now let's look at B and D. B, from S to B through C, 5 plus 9. So you get 14 there, 14 and C. And next one is S to C to D, 5 plus 2 is 7. So 7, right? And next one, you want to expand from D, or D here, because D is the lowest value, right? 7. As comparison between 7, 8, and 14 there, 7 is the lowest. So you want to expand from D. So now, S, C, D, what options do you have? You can go from D to where? D to B only, right? You can go to D because it goes from here to here, it goes to here to here, and now you cannot go back to S. You can only go to B, right? So B is the only thing that you want to update, right? So S to C to D to B is 5 plus 2 plus 6. So it's 7 plus 6 is 13 there. So 13 is lower than previous one, which is 14C. So you slash that one, you replace it by 13D. Okay. So now you already finish one cycle, because you already reached the goal point, which is B, with going through S, C, D, and then B. But then you know that there is another option that you can go, which is S to A or S to A or S to D directly. But then S to A here is lower in value kan tadi daripada 13 ni. So you can go to that A. So now you try to choose from A. S to A can go to where? Can go to B, right? Here. So 10 plus 1 is 11. Sorry, 8 plus 1 there, 8 there, because you know already. This one is you want to expand from A, but you know that the lowest distance is actually going through here and then going through here, not directly, because directly is 10. From here to here is only 8, right? So you want to go from S to C to A, and next option is only B. So you plus that 8 plus 1 there, then you get 9 here, 9A. So now you already get the final table. And how do you get from S to B? So you go back. Tadi macam ni, this is B, B going to A, there. Then A going to C, then C going to S. So just now, B going to A, and then C, and then S, S, C, A, B, like that. Faham? Do you understand? Understand or not? This one is just revision. You need to look again and what you need to calculate one by one. Sometimes sometimes you might have a mistake. So need to be very careful looking at the the direction and so on. Very important, this one. Understand or not? Any question?
No.
Not understand?
No, I mean no question.
No question. Understand? Edmund, okay?
Okay.
Okay. All right. It's okay. You go and revise again this one. Extra. You need to one by one. You look at the movement of the arrow and so on, and then see. Okay. Now, when as what I said just now, the A star is more efficient than Dijkstra because you have this equation, right? This equation, because here G is actually the distance between the current cell to the starting cell, and H is the distance between the current cell to the goal cell. So you have this additional information, right? Hn, which is the distance between the current cell to the goal cell. Okay, so how do you calculate that? So let's say you have the same problem like this, okay, and you also have the values inside the nodes there, which is 1 here, 3 here, and 5 here. These are actually the value of H. These are actually the value of H. So now let's say you want to solve from S to B, right? So S to B, you have only 3 options: to A, S to A, S to C, and S to D, right? So S to A, how do you calculate? S to A, you want to calculate is actually equals to F plus, sorry, this is G plus H. Susah lah pakai pen ni. Pakai whiteboard senang lagi ya. G plus H, right? So what you are calculating here actually, G here is actually 5 because it's the distance between the starting position S to sorry, A is here. Wala petang-petang ni. A is up there. So S to A is actually 10, right? So G there is 10. H there is actually 1, right? So that's why you get 11, which is here. Okay, now S to C is actually 5 plus 3. So you get 8. S D is actually 9 plus 5 there. So you get 14. Understand? Okay. Sekejap, I padam balik. Okay, now you solve one thing. You solve the A, C, and D. Now imagine from this you already know these 3 values, right? So which one is the lowest value? It's C here, right? This one is the lowest value. So you want to proceed from C. Now, as C, here C, you can go to D, you can go to B, you can go to A, right? So let's do the A first. So how do you calculate SCA? You plus this one, 5 plus 3 plus 1. Okay, 5 plus 3 plus 1, you get 9. And then SCB is 5 here, plus 9 plus 0, kan? So you get 5 plus 9 plus 0, you get 14. And last one is SCD, 5 plus 2 plus 5. 10. 5 plus 2 plus 5. So you get 12. So which one is the lowest? 9. 9 is the lowest. So now, from here, from D, now you have select this one, you have select this one, and sorry, A is the lowest. You have select this one, and you have select this one, right? Ni adalah merah ni. So now from A, you can only go to B, right? You can only go to B. So the only option is S to C to A to B. So 5 plus 3 plus 1 plus 0. So you get 9. And 9 there is actually already the shortest distance from S to B, because you don't need to calculate any more other direction because you already get the shortest there. Understand? So as I said just now, why is it more efficient? Because you have the value there. You have the value of age, which is in the node there, 1, 3, and 5 there, which represent what is the shortest distance between that node to the final position, to the goal position. And that information makes the computation punya steps towards the lowest value, the most efficient one. So you don't need to calculate in all direction. The one that you already calculate is already the most efficient one. Understand this one? Boleh tak?
Boleh.
Boleh ya? Sekejap. Okay. Now let's look at how we implement the path planning on occupancy grade. Because just now you see is on the topological map, right? Now how do we implement it on the occupancy grade? So let's say you have 5 by 5 cells where you have the starting position S and you have the starting goal position G. So how do you find the shortest path from S to G? Given that you have these 5 cells, 5 times 5 cells, which is 25 cells lah, 5 darab 5 kan, 25 cells. So the first thing that you need to understand, the first thing that you need to calculate, whether it's Dijkstra or A star, you need to calculate first. Let's say now it's A star lah. You need to calculate first what is the value of H and G lah, right? Like just now, you need to understand first what is the value of H and G. So in this slide, it shows you how to calculate the value of G first, right? G is actually the distance between the starting point to the cell. Now from S to here to here to here to here and to here, how do you calculate? How do you calculate? Kalau it's vertical or horizontal, you just add 1. You just add 1. But if it's diagonal, you times with 2, square root of 2. Understand? Kalau let's say from here to here, it's 1. From here to here, actually 1 times square root of 2. Kan? From here to here, it's 1. Here to here is 1 times square root of 2. And here also is actually 1. Okay. What if, let's ask you a question. What if I say, if I say that, okay, this map, this map, the cell to cell distance is 5 cm. How do you calculate? From here to here is what?
5.
5, correct. From here to here? 7 point. How do you calculate? Tangent lah. 5. Okay. Plus 5 power 2. Macam ni lah. Okay. Dapat apa? What do you get?
5 set 2.
Huh?
5 set 2.
5
Square
What?
root. Yeah.
So you see, this one is actually the same as macam ni. Sama tak? So 5 there is actually A. So you need to be very careful. So let's say in the question saying that, oh, the cell to cell distance is actually 5. Cell to cell distance is 100, or cell to cell distance is 10. So don't straight away calculate, okay, it's from here to here is square root of 2. No, you have to put there 5 kat sini, ataupun what, 10. Understand? This is actually the same lah. Contohnya tadi, let's say cell to cell is 10 cm. Then the way how you calculate is 10 square plus 10 square divide like this, right? It will be punca kuasa 200. But then it's actually the same as 10 to the power of square root 2. Faham tak? So senang you see it's A with the square root of 2, just like that. Okay? Let me clear everything. Banyak pula cantik. Mana nak clear semua? Padam satu ke? Okay, now let's say if I want to calculate here, what is the value of G? Macam ni ke? Satu, let's say the cell to cell is 1, plus 1 plus 1.
2.4.
Betul tak macam ni? Kalau saya letak 1 plus 1 plus 1 equals to 3. Is it correct or not? No, right?
No.
Because you need to see where is the shortest. Suppose the calculation should be, if you want to get x here, should be here and then here. right? For you to calculate G. Correct or not? So just okay. So G must be equals to square root of 2 plus 1, right? Which is you get 1 point what? Or 2.41 2.41 I think, if I'm not mistaken. Betul ke? 2.41.
Yes, 2 by 4 1.
So any time in the map, you need to be able to calculate what is G based on the position with respect to the starting point. Let's say like here also, the way how you get there, the shortest path would be like that, and then like that, right? So square root of G equals to square root of 2 plus square root of 2 plus 1. Kalau kat sini, it could be like here and then like that, right? But then it's okay because you are expanding, right? You are expanding the map. You are expanding the map step by step. Like this one, you are expanding first. This is the layer, and then you expand it like this, and then you expand it here, and then you expand it where something like that. It's expanding, so no problem for you to calculate. I just want to say that if you want to calculate, then you need to find the shortest way to that point, rather than you need the way how you calculate is like that. Okay, so that is how you calculate G. Then how do you calculate H actually? How do you calculate H? Just now is G, right? This is G, this is H. How do you calculate this value there? It is actually the distance, the straight line distance. Tadi is adjacent is A, diagonal is A times the power of 2. But then for H is a straight line distance. So let's say from here, the cell here, you need how you calculate, you need to find a straight line distance. So kalau X here, H must be 2 to the power of 2 plus 1 to the power of 2, right? Betul tak? Which is 2 here, ini 2, ini 1. Macam trigonometry, 2 here, 1 here, right? So 2 to the power of 2 plus 1 to the power of 2, and then you square root that one, then you get 5, like that. So the value that you see here on the maps is that value lah. The value that you see on the map here, the age that you see here, 4.12, 3.16 is that value. If 3.16 here is actually the value, the straight line distance from here to here. Understand? Faham? Okay. So that's why in the case study also we ask you to understand this, how you calculate H, how you calculate G. If you really do your case study yourself, you should be able to calculate all this. Kalau you case study you don't do because it's in a group, right? If you don't really do group ke individual, but then of course you discuss, right? If you don't do yourself, you just copy ke apa ke, hopefully you don't, then you will not be able to understand how you calculate and expand, because this one is very simple. This one you don't have the obstacles at the center or anywhere, right? Let's say you have a lot of obstacles. You have obstacles here, macam ni kalau ni obstacles. How do you calculate G and H and so on? Okay, now let's go back. Okay, so just now we already calculate G. Now we calculate H. H, you already know what is H. So the first step in A star, you need to calculate F. So F is equals to G plus H. So that's why you see in each cell here, you calculate also what is F. For example, in this cell, G equals to 1, which is from here to here is 1. And then H is actually the shortest distance between that cell to G, which is 3. So 1 plus 3, you get 4 there. Okay. Kalau kat sini pula, if it's here, then the distance from here to here is square root of 2, which is D. The H is the direct distance from here to here, which is 3 to the power of 2 plus 1 to the power of 2 equals to 3.16. 3.16. So that's why you get F equals to the power of 2 plus 3.16, and you get 4.57. Okay. So let's say most of the time in any questions lah, in any assignment ke, sometimes we do provide age. We don't want you to calculate age because it's going to be time consuming, right? So you can just use the value of age that is already provided. Okay. Only you need to calculate the F and so on lah, for you to know what is the distance. Okay, now how do you solve this? First, you have S there, right? So the options that you can go is here, 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 and here, and here. So first step, you need to calculate G, H, and F for each of these cells. So you see all this cell has been calculated, right? Okay, now you know that this is the lowest value of F. So you want to expand from this cell to the next possible action, which is here, here, and here. So that's why you see in the next step here, you calculate the value of this one, and this one. So now, once you know all this value, you see that this is the lowest value. So you want to expand from here, this one, to here, here, and here, right? So you get these three values. And again, this is the shortest one. So you want to expand to here already, right? Actually, but you need to calculate all these three, and then you get this one, and you know that this is the goal. So you already know that the path will be from here through there, because this is the lowest value of F, right? The lowest value of F is F4, 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 and F4 there. That is the lowest value that you want, that shows the shortest path from S to the goal position. Got it? Boleh? Kalau lah I say that this is 10 cm, what will be the value here? We'll calculate up. The value will be different. If it's 10 cm, then what will be the value? G equals to what? Ada calculator tak kat situ?
24.1 lah.
24.1. It's just time 10 je. H? What's the value of H? Must be the same, right?
Same, 22.4.
22.4. You see, it's only times 10 there. It's a mathematics punya dia proof lah. You just get out of the 10 and then times the what? If it's the unit is 1, then now the unit is 10 times, then you just 10 times that lah. G, 10 times H, 10 times F also. So you get altogether, you get again for F equals to is 6.5. Kalau kata if the cell size is 5, then you need to times 5 lah this one. Understand? Okay. Right. I just give you if the case is different, so you need to aware about that. Now, let's look at if you have you see here there is a obstacle there. Let's say if I want to calculate here, what would be the value of G and H? Sama tak dengan ni? Sama tak dengan ni? Is it would be the same like this one? The same or not?
Same.
The same. Why? Because G of course is the same, right? It's square root of 2. H the same or not?
Same.
No.
No or yes? Siapa kata yes angkat tangan?
No.
Siapa kata no? Okay, turun tangan balik. Lower your hand back. Who said no? Oh, tadi ramai cakap no. The answer is yes, the same. See this one. Mana contoh bawah ni? Okay. 4.6. Just now was 4.6 also. Right. Why is it the same? Because you see H here is apa definition of H is straight line distance. Or shortest distance or straight line distance without considering any obstacles. So it's actually as simple as that. So whether there is an obstacle or no obstacle at all, your value of H must be the same. Okay? Got it? So that's why your value of tadi tu, you get what? H must be 3.16 also. And then F must be 4.6. Roughly like that. This I just asked you just now to test whether you understand or not. Okay. Now, kalau kat sini, the value will be the same or not? With respect to, alamak, I choose this one. If it is this point, the value will be this one or not?
No.
No or yes?
No.
Who said yes? Raise your hand.
Can you repeat again?
Again? Was it?
Can you repeat again one just now you say?
Okay, let's say I say this point here, X, would the value of G, H, and F, ataupun only F, what the value of F, would be the same as without the obstacle, which is this one. Same or not? Just now we say that here is the same, right? But here, is it the same or not? This one? No or yes?
No. No.
No, doctor.
No.
No, because although age is always the same, because you only straight line distance without any obstacle whatsoever. But then from G to this point, you need to calculate like this, right? Something like that. The value will be like this. It will consider the obstacles, right? Kalau without the obstacle, just now you can just calculate like this. But now with the obstacle, it will be longer, right? The value of G will be different. All right. So that's just a quiz to test your understanding. But then it's not really related how you calculate. Okay. Now let's go into how you have. Let's say you have a extra and this kind of obstacles. How do you calculate from S to G? So the way how you expand it, I believe you already, I already taught you, right? So first you need to calculate the adjacent one. This is the same as previously. Okay, 1.4, and so on. Now you know from these 5 actions, you know that the smallest will be these 3, right? So from these 3, here, here, and here, you want to expand to here, and to here, right? And then this one also to here or to here, and last one to here and to here. So dengan kata lain, in other words, you want to expand to here lah. Sorry if it's hard for you to see. This is the only option because we are having online class. Merah biru susah saya nak tukar. Merah-merah je lah semua. Okay. So okay. So now you calculate this cell by using the just now the same formula. As direct to this part, this one is 1.4. From here to from here to here, 1 plus 1 you get 2, and so on. You know how to calculate already, right? Okay. Once you get this, then you see where you can expand anymore. You can only expand to this one, right? To here. So next step will be expanding to this cell, which is you cannot expand from 2.4 there, because actually 1.4 there is more lower. So sorry, just now it's not from here, it's actually from here. Okay, so 1.4 plus 1, you get 1.4, you get 2.8, which is the smallest distance to that. And then from this cell, you want to expand to here and to here, then you get 4.2 and 3.8 there. Then from this, you want to expand to here, you want to expand to here, and you want to expand to here. So you get the value, and then you expand from here to here, here to here, and here to, sorry, just now this one you expand also. Okay, so these two, so you get these two values, and finally because this value already more than 6.0, so you don't need to expand to here and here, because this value already more than 6.0. So you already got the answer. The shortest distance would be from S going to here, because and here and here. Understand? This is how you calculate the extra algorithm. You only need to calculate G. You don't need to calculate H at all. You don't need to calculate F. Based on the value of G alone, you should be able to see where is the path. But then again, as I said, it's not that efficient because you don't have the value of H just now. You only have the value of G. Okay, now let's look at A star. As I said, you need to calculate the value of H. Maybe in the questions you are given H already, you are given G already or whatsoever. So you need to be able to understand how to move forward. Or you are given H only, so you need to be able to calculate G and F and how do you solve everything. Okay, so for A star, same thing. You expand to here, here, and here, and here. You calculate G, F, G, H, and F, and see what is the lowest value of F. Now the lowest value of F is here, but then there is no option for you to expand anymore from that location, right? So the lowest value after that will be this one and this one, right? So now you try to expand from that to here and here and here, here and here, right? So you get the value of this, and this is the lowest one, and the only possible action is to here and here again, and then this would be the lowest value. So you expand to here, 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 and here. Then you get these 4 cells, and then based on that, you straight away reach the goal there, and then you get F equals to 5.6, and you already know the shortest distance based on the value of F to be like this. Understand? Boleh? Boleh kah? Any
Yes,
question?
Doctor.
Boleh? So this one is quite simple lah, but imagine if you have like very like this. You have 8 times 8, for example. Ni tak cukup 8. Let's say you have 8 times 8. And then you have S over here, and then G over here. Lepas tu you have like obstacle like this, obstacle like this, obstacle like this, for example. How do you calculate? You need to be able to calculate H, G, and F, and so on. If it's like this, then like this, right? You see that the obstacle doesn't cover everything, but then it covers a bit of some cells. So you straight away consider that these are the obstacles. Cannot go through. Macam ni, you see mana yang ni, all those intersect one, see that, oh, this is the obstacles. This one is the obstacle. So you don't go through this. So later when you expand it using A star or J star, you should be able to see, oh, probably this is the shortest distance. Or maybe it's going through here. Something like that. Understand? Okay. Any questions so far?
Doctor, I have one question.
Okay.
Actually, for the table, we need to do or not for the final exam?
You mean this one, You mean yang table, this one,
Yes.
No need.
Because it's too long.
No need.
Okay.
You can straight away calculate based on this one. You fill in GHF, GHF, and so on. Okay.
Okay, Doctor.
You straight away do this one, and then this one, and then next one, and so on. Okay. If you do the case study, you should be able to understand what everything, and then the steps. How do you find the final position and so on. Looking at this also, you understand, right? How do you find the shortest path? But very important for you to understand why A star is better than the Jackstra. Any more question? Same goes to Jackstra lah. Jackstra tadi, you don't need to draw the table like this. It's very tedious for you. If you draw this, you might take 1 hour just to answer this. If the question is out lah. I would say if the question for the past planning A star J star is out, you do this one, then you are done lah. I would say you are done with the lukis ni lah. Ada pula pakai pakai pembaris lah. 1, 2 buat pembaris macam tu, cantik je kan. Memang siap lah, tak siap lah you all punya ni. Yang ni 5 times 5. Imagine if it's 10 times 10 for example. Oh, panjang lagi lah you punya table kan. Silap tak muat kertas. Any more question? Kita santai hari ni. I don't like to see at the screen lah, seriously. Kalau tidak nampak muka Rashid, Lawinya ke kan. Ni nampak icon sekarang ni, you all ada yang tak bubuh gambar, you bubuh nombor je situ. Vincent V only ya. Dan Lawinya ada gambar. Zulfa ada gambar kartun kat situ, okey lah. Alright. Last question, no? No? Okay, so A star, J star consider, understand lah? No, kalau keluar tak nak salah. All must get it right if it's out in the exam. Okay, next one is about the navigation. Navigation, as I said, is how do you follow the path? You already set the path like that. That is the path, the shortest path. How do you actually follow the path using the mobile robot? So it's always related to the control of the robot. Let's say you are out a bit on the path, you want to correct, come back. You're out of path, you want to come back, and so on. That is the problem of navigation. Or let's say within the path you have an obstacle at the middle, so you want to go to the obstacle and then avoid it and then come back to the path and so on. Okay, and then these are the examples of navigation. And the last slide that I covered last time was about the AGV. Okay, so for AGV, I'm going to go through this. Okay, what is the difference between automated and autonomous? Automated is you already have all the well-defined set of parameters and a very focused task. So it is let's say like you have a line following in the AGV, right? It's following exactly the line and so on. So that is what you call as automated. While for the autonomous, it tries to adapt to the environment. Then the environment also might be a bit dynamic. You have obstacles running around and so on. So the robot should be able to avoid, to adapt to the environment, move along, and then of course you want to to solve certain application, right? So what is important in this thing is the navigation technique, right? For you, for AGV, you have different ways for the navigation. You have wire navigation, magnetic navigation, optical navigation, vision navigation, laser guided navigation, natural navigation using SLAM or LiDAR. But then let's say there is a scenario asking as a robotics engineer, let's say you become a robotics engineer later on, going out from the university, you become a robotic engineer. I give you a task, okay, develop what AGV for a warehouse, or develop AGV system for um, for a house, for a factory without a bumbung ataupun you have a very structured factory, but then you want to have many robots working at the same time. All these could be the challenge that you need to solve, right? Let's say you want to have one robot only working in a warehouse, for example. You don't need to consider about the schedules of the robots. You don't need to consider whether the robot might be colliding between each other and so on, right? But then let's say if I say you have multiple robots working together, then you need to be able to imagine whenever you have a lot of robot working together. Of course, you need to have what communications. You need to have scheduling. You need to make sure that the robot doesn't collide with each other. See, it's different in terms of how you design the whole system, right? Whenever I add one only, I say it's multi-robot. So you straight away comes to your mind, okay, it's multi-robot, you have additional problems. Or let's say I say, oh, you have a dynamic environment where the operator is moving around together while the robot is moving. So you straight away you say, oh, when there is operator moving around at the same time, you need to have what? Contoh. Let's say you have a robot and then you have operator moving around. What would be the problem? Anyone? Saya terdisconnect ke? Tak ada orang answer ni. Oh, ada. Siapa ni? Muhammad. Yes, that's right. Kalau ada operator moving at the same time, then you might have a collision, right? So what kind of things that you can think of to avoid this? How do you solve this? Boleh? You can say, or you have ultrasonic sensors to avoid from colliding the operator. What else you can have? You can have a lidar to avoid from ni kan, or you can have a mechanical bumper. A bumper to whenever it touch something, it will stop. It will do some emergency punya procedure and something like that. So these are the things that you need to imagine. You must be able to imagine. Let's say I say macam tadi is a you have multi-robot. Contoh lagi multi-robot. How what other things? Communication, for example, right? What kind of communication you might want to use? Can be a lot, right? You can have like I said in the beginning of the session just now, you can have a Wi-Fi, you can have and so on. Apa lagi? Kalau let's say you have a environment that is dark, gelap. What will be the problem? Khalid, what will be the problem? Are you there? No?
Yeah.
Khalid. Jack. Either Jack is okay. Which one? What will be the problem if you have a dark environment inside a factory, for example? Cannot think of it. The problem might be you cannot use a camera, isn't it? If it's dark, camera is not an option for you to use. The sensor will not be able to use. So you might opt for what? You might opt for laser scanning. You might opt for different kind of sensors lah. Understand? So all the specs that we provide to you, you need to be able to solve lah, based on the sensors, based on the sensing mechanism, based on the safety as well. Safety is very important also. Like what I said just now, no collision and so on. It's very important in terms of the battery, in terms of the communication and so on. So all this you need to consider. Okay. And let's say like this one, safety. Safety, you got two types. One is electronics, another one is mechanical, right? Mechanical, you know, is mechanical is something that is moving lah, something that is physical. You call it mechanical safety, mechanical protection. So mechanical protection, for example, you have bumper, right? Bumper, when you touch something, you stop. But then electronics kind of safety is, for example, you have sensors, you have sonar sensors, you have LiDAR, you have laser scanners and so on. You use this to avoid from obstacles. So this is what you call as safety based on electronics, electronic protection. Okay, understand? Okay, habis lah. Taknya habis. Saya cover dah 4 lecture. Itu patut satu jam saya cover semua. Okay. So what my point is, not only for you to answer exam, for you after you become an engineer and so on. My biggest point is you should be able to imagine. Whenever I give you a certain condition, you should be able to imagine what kind of, from A to Z lah, how from the beginning of the robotics, what kind of sensors you want to use, what kind of battery you want to use, what kind of motor that you want to use, and so on. And then after make up a system, what kind of locomotion that you want to be based on. Let's say it's differential or locomotion, or omnidirectional or steering based and so on. Once you get everything okay, then you can move. Then you need to think of, how do you solve certain application. Let's say there is a condition that is dark. There is a condition that you have operators moving around. You have a condition that is very big. How do you solve this? Or you need to have a flying robot, or you need to climb a wall or something like that. Then what kind of solutions that you need in order to do that? Possibly you need a slam, possibly you need a wire techniques, or probably you need line following technique. Probably you need to have, macam tadi, you have a lot of ways, right? Laser guided navigation as well, beacons and so on, in order to solve certain things. So if you understand all these, then given any problem, you should be able to design. You should be able to at least imagine how are you going to solve the problem. Okay? Of course lah, dalam exam you have all the calculation, right? So what apa je pun yang ada calculations dalam robotics? Kinematics, dynamics, and then A-star, G-star, all this, and then battery calculations, motor calculations, and so on. All these are the calculations. Apart from that, you have all these, how do you design, how do you make everything into one. So this you need to master lah before you go into exam. Any questions? Anything else? We have around 10 minutes before we end our session. Are you ready, guys, for the exam? It's okay, you have another Around 1 week. Roughly around 1 week. You have any more exam besides mobile robot? AMR?
Yes, doctor.
Yes.
What are the exams that you have? Oh, 2 more. Oh, okay. Right. Any more question? Lavinia? Okay.
Okay, Doctor.
Mana yang selalu cakap ni siapa nama dia?
Farouk.
Mana dia? Dia punya ni. Oh, kalau face to face banyak cakap noh. Tak ada lah. Farouk mana Farouk?
Tidur lah kot.
Ish, semalam dia kata siapa? Dalam WhatsApp tu kata apa? Ada benda dia kata dalam WhatsApp. Oh, saya tengok. Tapi tak main pula. Mana Farouk ni? Jangan duduk bilik lama sangat. Keluar sama sembang kawan. Sean okay, Sean?
Okay, sir.
Hariki.
Okay.
Lim Yi Hong. Henry.
Yes.
Okay.
Although I met you just once, I think I can still remember some of you. Jack. Azizi. Vincent. Zulfa ada 2 ni dalam ni. Okay, kalau tak ada question, ada question lagi before we end. Khalid, okay.
Nanti exam ni tanya balik lah.
Nanti apa? Tak dengar.
Tanya balik nanti exam ni.
Nanti nak exam nanti tanya balik boleh, insyaAllah. Tapi nak dekat exam tu saya busy kat noh. Ada beberapa event lah. Tapi bolehlah tanya WhatsApp ke apa ke. Nanti kalau sempat kita arrange. Melvin, okay. Apa Nur Jihad ada Jihad? Are you here Jihad? No?